Remember from Calc 1 that the chain rule is called the chain rule because when you have functions inside of functions inside of functions, you kept multiplying by these extra links. So having a chain rule where we can only go one layer deep isn't a chain rule at all. And so let's just look at the situation where it's a little more complicated. So z is a function of x and y, x is a function of u and v, y is a function of u and v, and now we go another layer deep. U is a function of more variables, v is a function of more variables. And what we want to do is say, look, if I hold r, if I let r vary and I hold s constant, then x and y, u and v are going to change a little bit, then x and y are going to change a little bit, then z is going to change a little bit, and we should be able to measure how fast z is changing when we let r vary but hold s constant. Now what are we supposed to do? Well, what we're supposed to do is go back to the differential like we always do in this chapter. So I'm just going to write down the differential. So delta z is zx times delta x plus zy times delta y. Now what are we supposed to do? Well, what we now need to do is figure out what delta x is. Well, delta x is a function of u and v. So what we're going to do is we're just going to write delta x. And again, these all should be estimates because these are locally linear, not necessarily linear. What is delta x going to be? Well, that should be the partial derivative of x with respect to u times delta u plus the partial derivative of x with respect to v times delta v. Y is very similar. Delta y is going to be yu delta u plus yv delta v, and we need to plug all of those in. So what we're going to get is delta z is approximately equal to zx, and instead of delta x I put its estimate, xu delta u plus xv delta v plus zy, and then put in for delta y, yu delta u plus yv delta v, and I'm going to now multiply through. I'm going to get zx, xu, yeah, I guess I'm stuck with that, right? Delta u plus zx, xv, delta v, plus zy, yu, delta u, plus zy, yv, delta v. And remember, what we're after is to let r vary and hold s constant, so we're going to divide both sides by delta s. So I'll put a little delta s there, little delta s there. I'm putting a delta s under each term. And I'm putting it under the delta. I could put it anywhere I want to under those things, but this is the best thing possible, I think. And so what we get is an estimate for delta z over delta s, and now we take the limit as delta s goes to 0, and we're going to get a formula for the partial derivative of z with respect to s, even though it's 2 layers deep. I'm going to get zx, xu, us, plus zx, xv, vs, plus zy, yu, us, plus zy, yv, vs. Now, this says basically if we can take all the partial derivatives with respect to everything, we can actually calculate this out. But it's not true that we're multiplying every derivative by every derivative. What we have to do is this one organized thing that ends up like this. And the best way I've ever seen to organize this is something they actually use in probability. It's called a tree. And we are going to calculate the formula the same way they calculate it in probability. Now when I say probability, this is the same kind of probability they do in Math 105. They use something called Bayes' theorem, and they have to make this exact same tree. Now, how am I going to make this tree? Well, at the top of the tree is z, right? Because that's where it started. And let's do it this way so I have more room, right? So this is what I'm going to do. I'm going to write down z. Now, z was a function of x and y. X is a function of u and v. Y was a function of u and v. And u was a function of r and s. V was a function of r and s. again, R and S. Now it's possible to write this down without all the repeating, but it loses a lot of the intuition. Now, what are we going to do with the tree? Well, what we're going to do is we're going to say, look, I want ZS, and I notice that there are 4 paths from the top of the tree down to S. So here's path number 1, right? Here's path number 2, like that. Now we're going down to S, right? So here's path number 3, like this. And here's path number 4. So it's going to come down like this, it's going to hit V, and then it's going to hit S like that. Actually, it has to go through Y. Now, why did I circle those paths? Because I just want you to notice what's down the path, right? What I see down the first path is X, Y, S. I'm sorry, it's X, U, S. And if you actually look at the first term here, you're going to see X, U, S. Now, how is this going to work? Well, the way we're going to use the tree is we're going to take derivatives down each branch and multiply them together. So the first derivative is going to be z with respect to x, and then I'm going to move down a little bit. It's going to be x with respect to u, and then down to the end of the branch it's going to be u with respect to s. And you can see we just wrote down the first piece of the chain rule. The second piece of the chain rule should correspond to the second path down. The second path down goes z, x, v, s like that. So I take the partial derivative of z with respect to x, so I write it like that. And then x with respect to v, like that. And then v with respect to s. Now this is, like I say, this is the same way they do it in probability. In probability, they multiply the probabilities down each branch and then add them together. We're taking partial derivatives down each branch and taking them together. The third branch looks like partial derivative of z with respect to y, and then partial derivative of y with respect to u, and then finally the partial derivative of u with respect to s. And you notice we're taking partial derivatives down the branch, we multiply them together, and that does give us the third piece of our chain rule down here. The last path down the tree goes z with respect to y, and then y with respect to v, and then v with respect to s. So there's nothing to prove here. This is just a way of organizing everything the way we need to be able to organize it and getting the right answer. So every time we have to do a chain rule problem, what we need to do is just make a tree and then write something like this, and then put in all the partial derivatives we have to take as we go along.